Visualizing electromagnetic fields in empty space. To better understand electromagnetic fields, it helps me to imagine being able to see them. I imagine that positive fields are black and negative fields are white. A negative particle would appear white, brightest at the center, and fainter moving out from the center. If it moved quickly, it would be brighter in the direction it is going and diminished when viewed from the opposite direction. Consider a straight wire carrying DC current through copper atoms. Looking along the wire from the positive end, we see the intensified fields in front of moving electrons as a white color of the wire and the space around it. In contrast, the very same wire viewed from the other direction would have a black color because the field behind the electrons are overshadowed by the positive protons in the copper atoms. When a magnet made from the same wire that is wound around a vertical core, the sides with electrons flowing towards us would appear whitish and the area around it, and the other blackish. Permanent magnets and the core mutually attract whenever their whitish and blackish sides are lined up. Next, consider a single hydrogen atom. In a hydrogen atom, a gray-black proton and the electron would mutually neutralize their fields, making the space clear everywhere except right in close to the nucleus and the electron. In close, we see a neutral gray field. We realize that the field in these charged spaces appears gray because part of the time it is white and part of the time it is black when it is further from the electron. Shortening our viewing time interval will remove the gray zones. In a shorter time interval, during which the electron moves very little, the field becomes gray-black around the proton and white around the electron. A bright white spot on the electron tells us which way it is moving. Outside the center, the fields still cancel each other, leaving clear space. However, we can still detect a very faint grayish donut shape around the proton, extending far beyond the center. To remove the remaining gray regions, we must again reduce the time interval still further. We now take an extremely small interval of time during which the electron and the quarks in the proton are all frozen in space. The gray-black proton is now two pure black quarks, up quarks, with a bright white down quark between them. All three have intense field spots in the direction they are circling within the proton space. Furthermore, they have tiny black or white wake zones of compressed fields curving outward to make three long, thin spirals reaching from the front of the quarks. We see that these spirals were the source of the faint gray donut region in the prior, less infinitesimal time interval. One might now consider the effect of a very large body of atoms with quarks, all producing the same black and white electromagnetic field spirals. They are forced by their identical physical characteristics and the speed of light constrained to align and contribute positive interference between like-charged spirals. The net effect being ultra-thin interference surfaces moving out at the speed of the light around celestial bodies, making giant bubble-shaped layers alternating black and white. Using this model, we find that our neutral, empty, clear space is actually intense gray space, We only test it as neutral gray because our smallest measurable time interval is many quark cycles too long. Instruments shall never be able, at least not that I can imagine, to measure fields over time intervals so far below normal thresholds. Thus, it is only in our mind's eye will we ever see the physical workings behind gravity. Thank you. Stop. Oh.